Hi everyone, in the last video we covered part 1 of JVM architecture where we have discussed the concept of the class loader. So if you have not watched that video yet, I have included link in the description box. Make sure to watch it first because without that background, this video on part 2 might not make much sense. So let's deep dive into part 2 of JVM architecture, that is JVM memory. So without wasting time, let's get started. So now let's see the first component, heap memory. So heap memory is the runtime memory area where all Java objects are stored. It is shared across all threads in JVM. If an object is created using new keyword, it goes to the heap memory. So heap memory is divided into two categories, young generation and old generation. You can see here it is divided into two categories. This is young generation and this is old generation. So what is young generation? Young generation is used for creating new objects. So all newly created objects are first stored in the young generation. So most objects are short-lived, so JVM keeps them into young generation. Now let's talk about hidden space. It is known as object birthplace. So whenever we create an object using new, it is allocated in hidden space. So here it is allocated. So next let's talk about survival spaces, that is S0 and S1. So it is also known as object survival test. So objects that are still in use are moved to survival spaces and it checks whether an object should live longer or not. Now let's talk about promotion. So promotion is nothing but moving to old generation. So objects that survive multiple times in young generations are promoted to old generation. So you can see here the objects which are created in hidden space and that are survived for longer time is getting promoted to older generations. So from younger generations, objects are getting moved to old generations. Now let's talk about old generation. So old generation is a place where objects are lived longer period of time. So old generation stores long living objects. Examples are singleton objects, cached objects, objects used throughout the life cycles are being lived for longer period of time. So most objects die young. So JVM optimizes memory by sharing short-lived and long-lived objects. So that is all about heap memory in JVM. Now let's move to the next part, Metaspace. So before moving to Metaspace concept, let's see a concept called PermGen which was introduced before Java 8 version. So PermGen concept comes inside heap area. So in heap area we have young generation, old generation, and the third is the PermGen which we are going to see now. So now let's see what is PermGen. So PermGen is special memory area in JVM before Java 8 which is used to store class related information and which is managed by JVM garbage collector and it does not store normal Java objects. So what does PermGen store? It stores class metadata like class structures, fields, method metadata, runtime constant pools, and static variables. So why does PermGen existed? To keep class metadata separate from objects and to improve JVM performance. So now let's see PermGen JVM options. So PermGen memory tuning options are below. -XX perm size, which means you need to pass the initial PermGen size. -XS max perm size. So you need to pass maximum PermGen size. So if you want to tune PermGen memory, you need to pass two parameters. First is the initial PermGen size and second is the maximum PermGen size. So now let's see what is the common PermGen error which we get. So the common error which we get is java.lang.out of memory error, which is the PermGen space error. So when does it occur? It occurs when too many classes are loaded and when PermGen size is too small. So this error is very common in web applications. So now let's see why PermGen was removed. So the reasons are it has fixed memory size, manual tuning is required, frequent out of memory errors and difficult garbage collections. So now we have completed the heap area which consists of young generation and old generation. PermGen also we have completed and now let's move to Metaspace area. What is Metaspace? Metaspace is memory area introduced in Java 8 and it replaces PermGen and store class related metadata and it is allocated in native memory. You can see here it is allocated in native memory which is outside heap memory. So what does Metaspace store? It stores class metadata, informations like class structures, fields, method metadata, runtime constant pool, static variables and JVM internal metadata. So why Metaspace was introduced? It was introduced to remove PermGen size limitations. We know PermGen was having size limitations. So Metaspace does not have any size limitations. It grows when required. It helps to reduce out of memory errors. It helps to simplify JVM memory management. So Metaspace JVM options. Metaspace tuning options are below. -XX Metaspace size, which means we need to pass here the initial size. -XX maximum Metaspace size, which means we need to pass here the maximum size, and also the maximum size is optional here. So Metaspace out of memory error. So error which we get in Metaspace is java.lang.out of memory error. So this error occurs when too many classes are loaded, class loaders are not released, maximum Metaspace size is reached if it is set. So this error is less common but still possible. Now this is just a comparison chart between PermGen versus Metaspace. So in PermGen, it was introduced before Java 8. Metaspace was introduced in Java 8 and later. It was a part of JVM Heap, and Metaspace uses native memory. So PermGen has a fixed size where Metaspace dynamically grows. In PermGen, manual tuning is required, while in Metaspace minimum tuning is required. In PermGen, we get out of memory errors frequently, but in Metaspace we rarely get out of memory error. So guys, till now, if you really found this video helpful, please do not forget to subscribe my channel so that you will never miss an update for my upcoming videos. Now let's go to JVM stacks. So JVM stack is created per thread. Each thread has its own stack. Stack stores method calls. For each method call, one stack frame is created. So stack frame contains local variables and method results. Stack works in LIFO order, last in first out. Last called method finishes first. Stack is thread free. One thread cannot access another thread stacks. So in stacks, memory is cleaned automatically. No garbage collector is needed. So in JVM stack, the common error which we get is stack overflow error. When does this error occurs? It occurs due to deep recursion, too many methods called. So we have completed all about JVM stack. Let's move to next topic. Let's see PC register now, which stands for program counter. PC register keeps tracks of which instructions the JVM should execute next. Each thread has its own PC register, so multiple threads can run independently without interfering with each other. The PC register stores the address of the current instructions, and after execution, it moves to the next one. For native method, the PC value is undefined because native code runs outside the JVM. So the overall, PC register acts like a pointer, helping the JVM know exactly where it is during execution. Now let's see native method stack. So native method stack is used for native methods. It works with Java native interfaces. It stores execution of C or C++ code. It is separated from the JVM stack. It is platform dependent. Platform dependent means a program can only run on a specific operating system or hardware. It is not used for normal Java methods. When Java call native code, execution moves to native method stack. So this is all about native method stack. So friends, till now we have completed the JVM memory, which contains topics like heap memory, Metaspace, JVM stacks, PC registers, native method stack. So in the next video, we are going to see what is the execution engine. So guys, if you really found this video helpful, please like the video, share the video to your friend circles, and subscribe to my channel. I have given complete Java playlist in the description box, and if you have any doubts regarding this video, you can put your doubts in the comment section. So whenever I get free times, I can look into it and solve your queries. Happy learning with Java, and see you in the next video.